Welcome, curious minds, to another deep dive. Today, we're plunging into a topic that's not just shaping our future, but actively transforming it right now. Artificial intelligence.
It really is everywhere, isn't it?
Absolutely.
Okay.
Think about it. AI is already revolutionizing healthcare, making transportation smarter, driving unprecedented economic growth, and, well, scientific breakthroughs, too. It feels like its potential is truly limitless.
It does, doesn't it? We see the headlines about AI accelerating discovery, automating these complex tasks, really pushing the boundaries of what we thought was possible. But, just as with any truly powerful technology, there's another side to that coin. And frankly, this side demands our full attention.
Absolutely. Because for all its immense promise, AI also introduces significant, and here's the key word, unique risks.
Unique, yes. That's
We're
important.
not talking about minor bugs here. These are profound impacts that can ripple across individuals, groups, entire organizations, and even, our planet.
Yeah.
To truly be well-informed about AI, we have to understand this double-edged sword.
And to help us navigate this pretty intricate landscape, our central guide for today's exploration is a groundbreaking document from the U.S. National Institute of Standards and Technology, better known as NIST.
Ah, NIST. Right.
We're diving into their AI Risk Management Framework, version 1.0. This framework is, well, it's a crucial tool designed to help organizations, big or small, effectively manage AI risks, fostering responsible development and deployment.
Okay, so that's our guidepost. Our mission today, then, is to unpack this framework. We're going to pull out the most important insights, some genuinely surprising facts, I think, and truly practical takeaways.
Yeah, the practical side is key.
Our goal is to help you understand not just what AI risks are, but how they can be thoroughly understood and effectively managed. Think of this as your personal shortcut to getting a comprehensive grasp on AI risk without feeling overwhelmed by dense technical documents.
It's a necessary shortcut, really, because AI risks are fundamentally different from what we're used to with traditional software. Here's a crucial distinction. Conventional software, once it's written and thoroughly tested, generally behaves predictably, right? Unless there's an actual coding error.
Right, it does what it's told me.
Exactly. But AI systems, especially those that continuously learn, they're different. They can be trained on data that changes over time, sometimes subtly, sometimes dramatically.
That's what's often called drift, right?
Yeah.
That's a fascinating and, frankly, quite concerning concept.
It is.
Because it means traditional, one-and-done testing just isn't enough.
Yeah.
Imagine a weather prediction AI that works perfectly when it's sunny. But over time, as climate patterns shift, maybe its accuracy slowly degrades without anyone noticing until a major storm hits.
Precisely. Its behavior changes or drifts in ways you never intended or perhaps even anticipated during development.
Wow.
And this challenge is compounded by the inherent complexity of AI. Many AI systems can be incredibly opaque, often referred to as a black box.
The black box, yeah. I hear that term a lot.
What that means is it's incredibly difficult to understand why they arrive at certain decisions or predictions. It's like having a magical oven that bakes perfect bread, but you have no idea what temperature it's actually running at or why it chose that specific time.
That's a great analogy.
This lack of explainability or interpretability, often coupled with insufficient documentation, significantly complicates the process of measuring and managing risk.
So it's not just that they change, it's that we can't always tell how or why they're changing or making the decisions they do. That sounds like a recipe for hidden problems, particularly if something goes wrong.
It absolutely can be.
Yeah.
And then there's the socio-technical nature of AI.
Socio-technical. Okay, what does that mean?
Unlike many traditional software applications that might exist more in isolation, AI systems are deeply intertwined with human behavior and broader societal dynamics. The risks, and often the benefits too, emerge from this complex interplay.
So it's not just the code itself.
Not at all. It's about how a system is used, who operates it, the social context of its deployment, and even how it interacts with other AI systems or human processes. If a medical diagnostic AI is perfectly accurate, but doctors ignore its recommendations because they don't trust it, or maybe they misuse it, you have a socio-technical risk.
That's a crucial distinction. It's not just about the technology, but about people and society interacting with it. And what about integrating parts from other sources? I imagine that adds another layer of complexity.
It certainly does. We're seeing an increasing reliance on third-party components, be it software, hardware, or even pre-trained data or models. This can definitely accelerate development.
Sure, saves time.
But it significantly complicates risk measurement. Imagine trying to assess the safety of a car if half its parts came from manufacturers who won't share their testing data or their methodologies.
Right, you don't know what's under the hood.
Exactly. If the risk metrics or methodologies used by external vendors don't align with your own, or if there's just a lack of transparency from that third party, understanding the full value chain of an AI system becomes a considerable challenge. Everyone involved, from developers to deployers, needs to manage these risks, whether the components are standalone or deeply integrated.
Okay.
And this really sets the stage for why a dedicated, comprehensive framework like NIST is so vital.
That makes perfect sense. So it's not enough to just trust that the third-party component works. You need to understand its inherent risks and how their methods align with yours. That sounds like a lot of work, and it leads me to wonder about the idea of eliminating all risk. Is that even possible or practical with AI?
That's a crucial question, and the framework addresses it head on. Attempting to eliminate all negative risk is indeed impractical and, frankly, often counterproductive.
Why counterproductive?
Well, because not every incident or failure can be completely prevented, and striving for zero risk can lead to really inefficient allocation of scarce resources. You could spend forever trying to nail down the last 0.1% of risk. Instead, organizations must embrace the concept of risk tolerance and risk prioritization.
So it's about being strategic with where you put your energy and resources.
Exactly. A robust risk management culture recognizes that not all AI risks are created equal. Organizations need clear guidelines for assessing the trustworthiness of each AI system they develop or deploy. This allows them to prioritize resources based on the assessed risk level and potential impact.
Okay.
Risks involving physical safety or legal liabilities, regulatory compliance, or significant negative impacts on individuals or society, those should always receive the highest priority and the most rigorous oversight. It's about making informed trade-offs and focusing resources where they matter most, rather than chasing an impossible ideal of complete risk elimination.
Got it. Be realistic and focused.
Which leads us perfectly into the bedrock of responsible AI, the 7 pillars of trustworthiness, as NIST calls them.
I love that framing, the 7 pillars of trustworthy AI. It gives us a clear set of goals. What are these pillars and how do they connect?
So the NIST framework identifies 7 trustworthiness characteristics as the core goals for responsible AI. Valid and reliable, safe, secure and resilient, accountable and transparent, explainable and interpretable, privacy enhanced, and fair with harmful bias managed.
Okay, that's quite a list.
It is. And what's crucial to understand is that these aren't isolated characteristics. They are deeply interconnected and often require balancing trade-offs.
Trade-offs, how so?
Well, for example, a system that is highly secure might, in some very specific contexts, need certain controls that could potentially impact fairness if not carefully designed. Or a highly accurate system might be completely opaque, making transparency a challenge. The goal isn't to hit 100% on each independently, but to find the right balance for its specific intended use.
So, it's about finding the right balance for its specific purpose, not just optimizing for one single characteristic. Let's start with the first one, valid and reliable. What do those terms mean in the context of AI?
Valid and reliable is considered the foundational pillar, really a necessary condition for trustworthiness. Validity refers to the confirmation that the AI system fulfills the requirements for its specific intended use.
So, it does what it's supposed to do.
Essentially, yes. Think of it like this. If you build a self-driving car, its validity means it actually stays in its lane and stops at red lights. It does exactly what it's built to do in the way it was intended. Reliability, on the other hand, is its ability to perform as required without failure over a given time interval and under given conditions.
So, consistency.
Exactly. It means it does those things consistently, day in and day out, without unexpected glitches under the conditions it's designed for.
And how do accuracy and robustness contribute to this?
Both accuracy and robustness are key components. Accuracy is about how close the system's results are to the true values or the desired outcome, but it's not just about a single number, you know?
Right. Context matters.
Measures of accuracy must consider things like false positive and false negative rates, how often it gets things wrong in specific ways, and how the AI interacts with humans in a team setting. Critically, it's about how generalizable its results are to the real world beyond the specific training data.
So, testing needs to reflect reality.
Absolutely. This means clearly defined and realistic test sets that truly represent real-world use cases. Robustness relates to how well the system handles unexpected or even deliberately manipulated inputs, think noisy data or adversarial attacks. While high accuracy is desirable, it alone isn't sufficient. The primary goal of AI risk management is minimizing potential negative impacts, which sometimes means human intervention is needed when the AI can't detect or correct its own errors.
That's a very practical consideration. So a system can be accurate on average, but if its failures are catastrophic in those rare instances, it's not truly trustworthy. Okay, what's next on our list? Safe.
Safety, simply put, means the AI system minimizes potential harm to people, property, and the environment.
Seems straightforward.
It includes avoiding unintended negative impacts and, importantly, demonstrating the ability to fail safely when pushed beyond its operational limits. It's about designing for graceful degradation rather than a catastrophic collapse.
Like that robot arm example.
Exactly. Think of a robot arm in a factory. If it senses a human too close, it needs to stop or slow down safely, not just freeze, or worse, continue operating regardless.
Okay. And secure and resilient. Those often get grouped together, don't they?
They're related but distinct. Security in AI focuses on avoiding, protecting against, responding to, and recovering from malicious attacks. This includes protecting against things like adversarial examples.
Those weird inputs that trick the AI.
Yeah, input specifically designed to fool the AI into making mistakes, and data poisoning, where malicious data is secretly introduced during training to corrupt the model. Resilience, however, is the ability to return to normal function quickly after any unexpected adverse event, whether it's an attack, a power outage, or just an unforeseen software glitch.
So security is about defense against deliberate attacks, while resilience is about bouncing back from any disruption.
That's a good way to put it. Security is about keeping the bad stuff out. Resilience is about getting back up quickly when something bad happens, whatever the cause.
Okay, that clarifies it. Next, accountable and transparent. This feels like a core tenet of responsible AI.
It is, absolutely. Trustworthy AI fundamentally depends on accountability. And accountability, in turn, really relies on transparency. Transparency means providing enough information about the AI system, its design, training data, model structure, deployment context, and even the decisions it makes, so that individuals interacting with it can understand what's happening.
Enough information for who, though? Does everyone need the full technical detail?
Good point. No, the information needs to be appropriate for the stage of the AI lifecycle and tailored to the user's role or knowledge level. An end user needs different information than a system auditor or a developer debugging the system.
It sounds like it's about opening up that black box as much as possible, but in a way that's actually useful for the right people at the right time.
Precisely. Meaningful transparency is essential for actionable redress. If an AI system makes an incorrect output or causes a negative impact, transparency provides the necessary information to understand what went wrong and how to potentially address it or appeal the decision.
No, transparency doesn't guarantee accuracy, right?
Exactly. It's important to note that a transparent system isn't automatically accurate or privacy enhanced or secure or fair, but without transparency, it's incredibly difficult to determine those qualities, especially as complex systems evolve over time. It's a prerequisite for verification.
That makes perfect sense. You can't fix what you can't see or even understand, which leads us nicely to explainable and interpretable. Are those the same as transparency?
They're very closely related, often used together, but there's a nuanced distinction in the NIST framework. Explainability refers to how the AI system works, the internal mechanisms and processes underlying its operation. It's about the how.
The mechanics.
Right. Interpretability refers to the meaning of the AI system's output in the context of its design purpose. It's about the what does this mean for me? Both help users and operators gain deeper insights into the system's functionality and trustworthiness. The idea here is to really debunk the myth that complex AI must always be a black box that we simply have to accept without understanding.
So explainability is the process description, and interpretability is understanding the result's meaning. How does this help manage risk specifically?
Well, a lack of explainability can lead to negative perceptions of risk or even actual risks if users misuse a system they don't fundamentally understand. By describing how an AI system functions, tailored to the user's role and skill level, we can manage this. Explainable systems are easier to debug, monitor, and document, which in turn supports more thorough audits and governance.
And interpretability.
Interpretability helps by communicating why a particular prediction or recommendation was made. Both contribute to informed use and responsible governance, helping end users understand the system's purpose, its potential impact, and critically, when not to trust its output.
Knowing when not to trust it. That's key. Then we have privacy enhanced. This one seems self-explanatory, but I imagine it's more complex with AI, given how much data it consumes.
It is quite complex. AI systems collect, store, and process vast amounts of data throughout their life cycle. Protecting privacy means managing this data responsibly at every single stage. This includes ensuring appropriate data collection limitations, secure storage, defined processing purposes, and considering contextual integrity.
Contextual integrity, what's that?
It means basically is the data being used in ways that are consistent with the original context in which it was collected. For example, inferring sensitive information about someone's health or financial status from what seems like innocuous data points like browsing history or location data could violate contextual integrity.
Ah, so using data in ways people didn't expect or consent to.
Right, and this could lead to adverse decisions, which the framework refers to as allocative harms. Imagine an AI-powered hiring tool that subtly infers a job candidate's protected characteristic from their application data, leading to an unfair discriminatory decision. That's a privacy-related harm.
That's a serious concern. And finally, a really big one. Fair with harmful bias managed. This is the topic that comes up constantly when we talk about AI.
Absolutely. And the concept of bias in AI is incredibly nuanced. It's important to understand that bias isn't always negative in a technical sense. It's a deviation from a baseline, and sometimes it's even intended in statistics. However, AI systems can easily perpetuate and amplify harmful biases that exist in society or data, leading to negative impacts and discrimination.
So how does NIST categorize these harmful biases?
The framework highlights three major categories of AI bias to be managed. First, there's systemic bias, which exists in society, organizations, and data sets reflecting historical inequities or societal prejudices.
The bias baked into the world, basically.
Pretty much. Second, there's computational and statistical bias, often stemming from things like sampling errors, non-representative samples in data, or even flawed assumptions in the algorithms themselves. And third, there's human cognitive bias, which relates to how humans perceive, interpret, and interact with AI, bringing their own assumptions, stereotypes, or flawed heuristics into the process.
So it's not just about making sure your training data is perfectly balanced demographically. It's about understanding bias at every level: societal, technical, and human interaction.
Precisely. Managing harmful bias is crucial for preventing unfair outcomes. It requires looking beyond just simple demographic parity and delving into issues like representational harms, for example. If an AI image generator consistently depicts certain professions only with one gender or race, reinforcing stereotypes.
Like the CEO example.
Right. Or allocative harms, which we just discussed, the unequal distribution of resources or opportunities like loan applications or hiring decisions being skewed. This involves conducting fairness assessments across different groups, using context-specific fairness metrics like statistical parity or error rate equality to truly understand how system performance varies. It's about designing mechanisms to question decisions, provide redress, and course-correct, enhancing an organization's ability to manage these risks before they become deeply ingrained.
Wow. That's a comprehensive set of characteristics. It's clear these aren't just technical considerations, they're deeply ethical and societal ones. Now, how do all these characteristics and risks play out across the entire lifespan of an AI system? You mentioned a life cycle.
That brings us to the AI lifecycle, which NIST maps out. It's visualized as a continuous process where risk management needs to be infused from the very beginning, not just bolted on at the end. The lifecycle stages help us understand where and how risks might emerge, and importantly, who needs to be involved at each step.
Okay, walk us through it. What are the key stages?
It starts, logically, with the plan and design stage. This is where the initial concepts, objectives, and assumptions for the AI system are laid out. Crucially, potential impacts and ethical considerations should be front and center from day one. This is where you proactively incorporate those trustworthiness characteristics we just discussed into the system requirements.
So thinking about fairness and safety right from the blueprint stage.
Exactly. Next is data and input. This involves collecting, processing, cleaning, and validating the data the AI system will learn from. This stage includes critical internal and external validation checks, along with careful consideration of data lineage and quality, really understanding where your data came from and how good it is. Garbage in, garbage out, right?
Right, the classic problem. So planning and data are foundational. What about the actual AI model itself?
That's the AI model stage, which NIST breaks into two parts. Build and use, where algorithms are created, models are trained, tuned, and maybe put into initial limited use. And verify and validate, where those models are rigorously tested, evaluated, and their outputs interpreted to ensure they meet the requirements.
So build it, then really kick the tires.
Pretty much. This involves documenting test sets, metrics, and tools used for what NIST calls test, evaluation, validation, and verification, or TEVV. These evaluations should be representative of the relevant population and, particularly for bias, utilize those disaggregated evaluation methods we mentioned, breaking down results by group to identify and mitigate issues across different demographics.
And once the model is built and validated, it moves into action in the real world.
Exactly. That's the task and output stage, where the system is actually deployed and used for its intended task. This involves things like piloting, checking compatibility with existing systems, verifying regulatory compliance before full launch, and evaluating the user experience.
Okay, it's live. But it's not over then.
Not at all. Next comes the application context stage. This involves operating and continuously monitoring the AI system for its intended and unintended impacts, ensuring ongoing compliance with legal and regulatory requirements. This is where you watch for that drift in production data drift, model drift, concept drift, where changes in the real world might cause the AI's performance to degrade, requiring early detection and rapid intervention.
So it's not a one-and-done deployment. It's about continuous monitoring and adaptation. And who are the people involved across all these stages? Because it sounds like it's way more than just data scientists and engineers.
You're absolutely right. Effective AI risk management is a deeply collaborative effort involving a diverse ecosystem of what NIST calls AI actors. These are the different groups involved across the entire life cycle, and each has a distinct role and perspective on trustworthiness. Imagine building a complex bridge.
Right. You need more than just the engineers.
Exactly. You have city planners, environmental scientists, steel workers, safety inspectors, and the local community all playing a part. It's the same idea with AI.
So who exactly are these different actors in the AI context?
Well, at the plan and design stage, you have folks like system operators, potential end users, domain experts who know the field, AI designers, impact assessors, and crucially, C-suite executives, including legal and compliance officers setting the direction.
A broad group right from the start.
Yes. In data and input, you bring in data scientists, data engineers, maybe external data providers, domain experts again, sociocultural analysts to understand potential biases, and human factors experts looking at usability. For the AI model stage, both building and verifying, you have modelers, software engineers, data scientists, and specialized testing and validation experts, perhaps independent ones.
So a lot of technical and domain-specific roles there. What about when it's deployed and actually being used out in the wild?
In the task and output stage, the system integrators, developers, domain experts, and maybe third-party suppliers are all critical, along with compliance folks and human factors experts ensuring it works well for users. And in the application context, you have system operators, end users providing feedback, impact assessors monitoring effects, and again, those monitoring compliance and human factors over time.
Okay. But you mentioned it extends even further to people and planet.
Yes, the framework explicitly includes a people and planet perspective, considering how the AI is used or impacts individuals, communities, and the environment more broadly. This is where the real-world consequences land.
So who falls under that category?
This includes end users, operators, and practitioners using the AI, but also impacted individuals and communities who might not directly use it, but feel its effects. It also includes the general public, policymakers setting rules, standards organizations like NIST itself, advocacy groups, and civil society organizations raising concerns or providing input.
Wow. It's a huge ecosystem.
It is. And the key takeaway is that each of these actors has a different role in identifying, managing, and experiencing AI risks, and different perspectives on what makes an AI system trustworthy. This broad engagement, consultation with external personnel, and having a diverse team in terms of demographics, disciplines, backgrounds, and lived experiences is absolutely essential for truly comprehensive and effective AI risk management. It really highlights the truly collaborative and interdisciplinary nature of doing AI responsibly.
That really brings home the point that AI risk isn't just a technical problem locked away in a lab. It's a problem for everyone involved in its creation, deployment, and even those just impacted by it downstream. Now that we understand the life cycle and the actors, let's dive into the 4 core functions of the NIST AI RMF itself: govern, map, measure, and manage. These sound like the action verbs that bring the framework to life.
They are. These 4 functions organize AI risk management activities at their highest level, and govern is the crucial starting point, really the cross-cutting function that sets the rules and culture for everything else.
So govern isn't just step 1 in a linear process. It's more like the overarching policy and culture for handling AI risks throughout the organization, right?
Precisely. Govern is a continuous, overarching function infused throughout the entire AI RMF. It's about establishing the foundational policies, processes, procedures, and practices across the organization related to AI risk. It essentially sets the tone and the framework for how AI risks will be identified, assessed, and responded to. Strong governance drives an organizational culture that prioritizes risk management and ensures accountability from top leadership all the way down.
So it's about the very ethos of the organization when it comes to AI. And that starts with making sure you're playing by the rules, legally speaking, I imagine. That must be Govern 1.1.
Absolutely. A core part of govern is understanding, managing, and documenting all applicable legal and regulatory requirements involving AI. This includes things like non-discrimination laws, data privacy and security regulations like GDPR or state-level rules, accessibility requirements, and even sector-specific rules that might apply if you're deploying AI in healthcare, like iPay or finance.
That sounds like a moving target, too, given how quickly AI regulations are evolving globally.
It is. Organizations need to stay aware of these and ensure staff are appropriately trained and retrained because legal risks, such as those related to using AI in hiring or employment activities that might inadvertently affect persons with disabilities, can be significant.
Okay, so understanding the law is foundational. How does an organization ensure accountability and clear communication within this complex environment? That sounds like Govern 2.1.
That's all about clearly defining roles, responsibilities, authorities, and lines of communication for managing AI risks. This is absolutely critical for developing that risk-aware organizational culture we talked about.
You give an example.
Sure. The framework suggests, for instance, that professionals carrying out testing and evaluation tasks, the TEVV activities, should ideally be independent from the AI system developers themselves.
Oh, independent verification.
Right. And they might report directly through risk management functions or even straight to executive.
Ah, that's smart. That kind of structure helps prevent biases, like groupthink or the sunk cost fallacy. We've already invested so much, we can't stop now, from derailing risk management efforts. It ensures that concerns aren't easily bypassed or swept under the rug.
Exactly. It fosters a culture where design and implementation decisions can be questioned and potentially corrected by empowered AI actors, allowing organizations to anticipate and manage risks before they become deeply ingrained or cause harm.
And building on that, how do organizations foster a broader safety-first mindset throughout their work with AI? That seems to be Govern 4.1.
This means establishing organizational policies and practices that actively incentivize critical thinking and a safety-first approach in AI design, development, deployment, and ongoing use. This includes concepts like implementing 3 lines of defense, where different teams have distinct responsibilities for risk ownership, oversight, and independent assurance.
Okay.
It also involves practices like red teaming, where dedicated teams actively try to break the system or find vulnerabilities, stress testing it adversarially to identify weaknesses before malicious actors do.
Proactive defense.
And crucially, the framework emphasizes establishing whistleblower protections for insiders who report serious problems or ethical concerns with AI systems. This fosters an environment where people feel safe to raise concerns rather than suppressing them for fear of reprisal.
That's vital. You absolutely need to empower people to speak up. And what about when an AI system has served its purpose? Or maybe it just becomes too risky to continue using? What's the protocol for that? I saw something about decommissioning Govern 1.7.
That's a surprising but incredibly vital point, often overlooked in the excitement of building new AI. The need for processes and procedures for safely and systematically decommissioning AI systems.
Sunsetting the AI.
Exactly.
Hmm.
When an AI system is no longer needed, or if its risks become unacceptable over time, organizations need clear policies for its removal from service. This isn't just flipping a switch. It includes addressing concerns from users and the community, ensuring business continuity if needed, complying with regulatory requirements like data retention laws, and preserving necessary information for potential future legal or forensic investigations.
So you might need the logs later.
You might. Decommissioned models or systems, along with ancillary data needed to understand them, should ideally be stored in an inventory for an established period. It's like responsibly recycling or disposing of old physical equipment, but for complex software systems with potential long-term impacts.
So it's not just about building AI. It's also about responsibly retiring it when the time comes. That makes a lot of sense. Now, let's move to the second pillar, MAP. How do we define the AI landscape for a specific system?
The MAP function is all about establishing the context. It's where you truly understand the AI system's specific landscape, defining its purpose clearly, and identifying its potential impacts, both good and bad. Imagine you're about to embark on a long journey. MAP is where you pull out the map, understand your destination, chart your route, and identify potential hazards along the way.
So this is where you figure out precisely what the AI is supposed to do, where it's going to operate, and for whom. That sounds like MAP 1.1, establishing context.
Precisely. This involves deeply understanding the AI system's intended purpose, its potentially beneficial uses, and, critically, exploring both its potential positive and negative impacts on individuals, communities, organizations, society, even the planet. You need to document the specific settings and expectations for its deployment, along with any underlying assumptions and limitations that might affect its performance or risks throughout its life cycle. This is where you proactively consider those socio-technical factors we discussed earlier.
And it sounds like you also need to clearly set boundaries for the AI system itself, what it can and cannot do, like MAP 2.1.
Exactly. It's vital to document exactly what the AI system is designed to do, what its knowledge limits are, where its competence ends, and under what conditions it is not intended to operate. This helps prevent off-label or inappropriate uses that could lead to unforeseen risks or harms.
So keeping it in its lane.
Right. If an AI is designed to recommend movies, it absolutely shouldn't be used off-label to make medical diagnoses or financial advice. Setting those boundaries clearly is crucial.
Got it. And what about the human element in interacting with these systems? How do humans and AI work together effectively and safely? MAP 2.2 covers this.
That's a key part of the MAP function, focusing on the human AI configuration. Organizations must define how humans will interact with and oversee AI systems, especially when the AI's output is used for consequential decision-making decisions that significantly impact people's lives or safety.
So it's not just about the AI, but the whole human AI team.
Correct. This means designing for seamless human workflows and providing the right tool sets and ensuring absolute clarity on who is responsible for what. It's about leveraging human expertise, judgment, and oversight rather than simply replacing it blindly. It also means understanding how human decision-making might be affected by the AI potential biases like automation bias, over-reliance on the AI, or selective adherence, only trusting the AI when it confirms prior beliefs need to be considered.
It sounds like it's about making sure the humans in the loop truly understand their role, the AI's limitations and potential pitfalls, especially when critical decisions are on the line. But even with careful planning, it's hard to anticipate every possible negative outcome, isn't it? How does the framework address that unknown aspect? That seems like MOP 3.2.
That's the challenge addressed in anticipating negative impacts. Foreseeing every potential AI error or unintended consequence is incredibly difficult, especially with complex adaptive systems. This function calls for organizations to examine and document potential costs, both monetary and non-monetary, that could result from AI failures or trustworthiness issues.
How do you anticipate the unanticipated?
It requires working with a broad set of stakeholders, including domain experts, ethicists, social scientists, and external AI actors like affected communities to improve their capacity for understanding these potential negative impacts, especially when they are not direct or immediately obvious. It's about actively trying to overcome failures of imagination by drawing on diverse perspectives and experiences.
So bringing in as many viewpoints as possible to brainstorm potential problems. And finally, for MAP, we revisit those third-party risks, what we're bringing in from outside. MAP 4.1.
Yes, this section specifically emphasizes identifying and documenting the risks of using third-party data, software components, or pre-trained models. This includes not just performance risks, but also legal risks, such as potential intellectual property infringement if training data wasn't properly licensed. This is where the supply chain of AI systems truly becomes critical.
Understanding the ingredients.
Exactly. Organizations must understand the provenance of content or data, how pre-trained models were created, what data they saw, what biases they might contain, and implement policies for collection, retention, and quality assessment of third-party data to prevent risks like intellectual property violations or the accidental inclusion of dangerous, harmful, or biased content.
Okay, so MAP is about thoroughly understanding the AI's purpose, its boundaries, how humans fit in, potential pitfalls, and the risks coming from external components.
Cool.
Once we've mapped the landscape thoroughly, how do we actually quantify these risks? That brings us to the third function, measure.
Right. The measure function is all about applying the tools and methodologies to analyze, assess, and monitor AI risk and its related impacts. It takes the context and potential issues identified in the MAP function and provides the concrete data needed to inform the decisions made in the manage function. Think of it as putting the AI system through its paces under a microscope, collecting all the crucial data about its performance, reliability, fairness, and potential weaknesses.
So this is where we get into the nitty-gritty of metrics, testing, evaluation, validation, all that rigorous stuff. Like Measure
Yeah.
1.1.
Exactly. This part focuses on identifying and applying appropriate methods and metrics. This involves selecting quantitative measures like accuracy rates, error rates, qualitative methods like user studies, expert reviews, or mixed method approaches to measure AI risks, starting with the most significant ones identified during MAP. It also requires documenting any known risks or trustworthiness characteristics that cannot or will not be measured for whatever reason. Transparency about measurement limitations is key.
Being honest about what you don't know or can't measure. And then the actual testing and validation processes themselves. What does that involve according to Measure 2.1 and 2.3?
This covers documenting all the taste sets, specific metrics, and tools used during their test, evaluation, validation, and verification, the TEVV processes. It's crucial to measure performance under conditions that are as similar as possible to the actual deployment setting. This includes analyzing things like false positive and false negative rates, system efficiency, robustness to noisy inputs, and documenting any significant differences between the test environment and the real-world deployment environment.
Does it go beyond standard testing?
Yes, the framework also mentions applying approaches like chaos engineering, deliberately introducing unexpected events or failures to gauge the system's resilience and ensure it can fail safely or gracefully degrade, rather than collapsing catastrophically.
Testing sounds critical, but what about evaluations involving actual people or data derived from them? Are there specific ethical and legal considerations when people are involved? Measure 2.2 touches on this.
Absolutely, and that's a key part of Measure. For any evaluations involving human subjects or data derived from them, organizations must meet all applicable legal and ethical requirements. This includes adhering to human subject protection protocols, like obtaining informed consent and ensuring privacy. Furthermore, these evaluations must use data or participant groups that are representative of the relevant population the AI will affect.
And how does measurement address bias specifically? That's Measure 2.11.
To identify and mitigate bias, it's crucial to utilize disaggregated evaluation methods. This means you don't just look at the overall average performance, you analyze results broken down by relevant demographic categories like race, age, gender, ability, location, or other context-specific factors. For bias specifically, this involves conducting fairness assessments across these different groups and applying context-specific fairness metrics like statistical parity, equal opportunity, or error rate equality to truly understand how performance varies and who might be unfairly advantaged or disadvantaged.
So it's about going beyond those overall averages to see the specific impacts on different groups. That's really important. And what happens once the AI system is out in the real world? How do you keep an eye on it then? That drift problem, again, covered in Measure 2.4.
That's continuous monitoring in production. AI systems operating in dynamic, real-world environments are susceptible to drift. Whether it's data drift, changes in the input data patterns, like new slang confusing a language model drift, the model's predictive performance degrading over time, like our earlier weather AI example, or concept drift. The underlying relationship the model is trying to capture actually changes in the real world.
So the world changes around the AI.
Exactly. Regular monitoring of how metrics and performance indicators change in these real-world settings is crucial for early detection and rapid intervention when AI systems no longer meet their original design assumptions or performance requirements. It's about being proactive as the environment evolves, not waiting for a catastrophic failure to realize something drifted.
So you're constantly checking its pulse, making sure it's still aligned with reality. And how do we measure the other trustworthiness characteristics like security, safety, and explainability? That seems covered in 2.6, 2.7, and 2.9.
Yeah. These are also addressed under Measure. For safety, Measure 2.6. This involves tracking things like out-of-range performance, how often the system operates near its known limits, and incident response times, for example. How quickly does an autonomous vehicle react and stop when an unexpected obstacle appears? For security, Measure 2.7, it's about using activities like red teaming and penetration testing to rigorously test the system's resilience to various attacks, and then modifying security procedures based on the results from testing and any real-world security events.
And explainability. How do you measure if an explanation is actually good?
For explainability, measure 2.9, it means measuring whether users can effectively understand the system's outputs and use the explanations provided to, say, debug errors or make informed decisions. This might involve user studies, tracking task completion rates with a versus without explanations, or assessing if the explanations provided are sufficient for investigating error sources.
Okay. And finally, a measurement that's becoming increasingly relevant.
Hmm.
Environmental impact, measure 2.1F. I imagine training these massive models isn't exactly carbon neutral or water sipping.
Indeed. This subcategory covers assessing and documenting the environmental impact and sustainability of AI model training and ongoing management activities. Training and operating large AI models, especially foundation models, require truly significant computational resources.
Huge amounts of power.
Yes, which translates to considerable energy and often water consumption for cooling data centers and associated greenhouse gas emissions. While measuring this impact accurately and consistently is still an emerging area for the industry, organizations are increasingly expected to assess, document, and potentially mitigate it where feasible. This applies particularly to large generative AI models, which have substantial resource demands for both training and ongoing operation inference. It's a real-world cost we're only beginning to fully quantify and account for.
So measure is about constantly gathering data, testing rigorously, monitoring continuously across all these different dimensions: performance, fairness, safety, security, even environmental impact. Once we have all that data, how do we act on it? That brings us to the final core function: manage.
Right, the manage function is where the rubber meets the road. It's about prioritizing, responding to, and continuously managing AI risks based on all the context, assessments, and analytical outputs gathered from the map and measure functions. This is where you make those tough decisions and take action.
So this is where the crucial decisions are made. Is this where the go-no-go call happens for deploying an AI? That sounds like manage 1.1.
Exactly. A key part of manage is making that crucial determination. Based on all the evidence gathered, does the AI system truly achieve its intended purpose and objectives within acceptable risk levels, and should its development or deployment proceed, continue, or perhaps be halted?
A formal checkpoint.
Yes. This involves formally weighing the AI system's identified negative risks against its anticipated benefits. It also means regularly assessing and documenting decisions made about those trade-offs among trustworthiness characteristics. For instance, deciding whether to deploy a system based primarily on its impressive performance versus its slightly less robust transparency or explainability. These assessments need to be continuous throughout the AI lifecycle, not just a single one-time gate at the beginning.
So it's not a set it and forget it decision, it's ongoing evaluation. And what if the risks are deemed too high, or perhaps unavoidable but need to be addressed? What are the options then? Manage 1.3 covers risk treatment.
That brings us to the standard risk treatment options. Once a risk is identified and assessed, organizations typically have four main responses available. First, you can try to mitigate the risk-taking actions to reduce its likelihood or impact, perhaps by improving the model, adding safeguards, or enhancing training data.
Okay, fix it.
Second, you can transfer the risk-shifting responsibility or financial burden to another party, maybe through insurance policies or specific clauses in contracts with a third-party vendor. Third, you can avoid the risk, deciding not to engage in the activity that creates the risk at all, perhaps by scrapping the AI project entirely or significantly narrowing its scope.
Just don't do it.
Or fourth, you can accept the risk, formally deciding to live with the risk, usually because the potential benefits are deemed to significantly outweigh the residual risk or the cost of mitigation is prohibitive. The framework explicitly states that organizations should prioritize risks involving physical safety, legal liabilities, regulatory compliance, and significant negative impacts on individuals, groups, or society when deciding how to treat them. Acceptance should be a conscious, documented decision, especially for high-impact risks.
And even after you've treated those risks, mitigated some, maybe transferred others, some may still remain, right? That's where residual risk comes in, mentioned in Manage 1.4.
Correct. Manage 1.4 focuses on documenting negative residual risks. These are the known, unmitigated risks that remain after risk treatment actions have been taken. What's crucial here is that these residual risks often directly impact end users, downstream AI actors, or the broader public.
The people need to know about them.
Absolutely. Transparent documentation of these accepted residual risks is vital to inform affected parties about the potential negative impacts they might encounter when interacting with the system. This fosters trust by being upfront and enables people to make their own informed decisions about using the system or how to interact with it cautiously. It's about full disclosure of what risks an organization is choosing to accept, potentially on behalf of its users or society.
That's a powerful concept, making sure the people who are actually affected by the AI know what they're potentially getting into. But AI is dynamic, things change, and new unknown risks can always emerge even after deployment.
Yeah.
How do you manage those unexpected surprises? Manage 2.3 seems relevant here.
That's the focus of Manage 2.3. Establishing procedures to respond to and recover from previously unknown risks when they are identified during operation. AI systems can exhibit truly unexpected emergent behavior or be subjected to novel attacks or exploits that weren't anticipated even during rigorous red teaming.
The infamous unknown unknowns.
Exactly. Organizations need documented protocols and clear lines of authority for continual monitoring and rapid response to these previously unidentified risks. This includes having contingency plans and defined thresholds for potentially deactivating, pausing, or bypassing systems if necessary to prevent harm. Any such incident requires thorough documentation, root cause analysis, and review to understand what happened and adapt procedures and potentially the system itself for the future.
So continuous vigilance and a plan B, and maybe C for the unexpected. What about those third-party AI systems we talked about earlier? Does the manage function apply specifically to managing risks associated with them? Manage 3.1?
Absolutely. Manage 3.1 specifically addresses managing risks related to third-party AI systems or components. Organizations must apply their own established organizational risk tolerance levels and risk management plans to any third-party AI technology, personnel, or resources they utilize. You can't just outsource the risk entirely.
You're still responsible.
Right. This is especially important for things like pre-trained models, which often lack detailed documentation and transparency about their training data or internal workings, making a full root cause analysis difficult if problems arise. Organizations need processes to independently and continually monitor the performance, security, fairness, and overall trustworthiness of these third-party components, not just blindly trust the vendor's claims.
Makes sense. And finally, this whole govern, map, measure, manage cycle. And it isn't a one-time project, is it? Sounds like a continuous journey, not a destination. Manage 4.1 points to continuous improvement.
No, it's definitely not a one-time thing. Manage 4.1 emphasizes continuous improvement. AI risk management is fundamentally an ongoing, iterative, cyclical process. Organizations must continually assess risks, learn from experience, including incidents and near misses, adapt their policies and procedures, and track system changes to enhance the quality, accuracy, fairness, security, and overall reliability of their AI systems over time.
Closing the loop.
Exactly. This involves feeding insights gained from monitoring, incidents, and user feedback directly back into the design, development, and governance processes, ensuring that lessons learned lead to concrete improvements. It's a dynamic process that demands constant vigilance, adaptation, and a commitment to learning.
So govern, map, measure, and manage a constant loop of setting rules and culture, understanding the context, quantifying the risks, and then responding, adapting, and learning. That's incredibly comprehensive for general AI systems. But let's zoom in now on a specific and increasingly relevant area. Generative AI. How does this framework apply to systems like large language models or image generators? Are there special considerations or unique challenges?
That's a great question. Generative AI, or GAI, truly presents a special case for risk management. While the RMF provides a robust and flexible foundation that absolutely still applies, GAI systems tend to amplify many existing AI risks and also introduce some new, unique challenges due to their incredible scale, versatility, and, well, their generative capabilities.
Oh, so what makes them so different from, say, a more traditional classification or prediction AI system we've discussed?
Firstly, it's the sheer scale and scope of their potential impact. GAI systems like large language models, LLMs, or text-to-image models can produce novel content, text, images, code, audio with unprecedented ease, realism, and volume. This means that if a risk manifests, say, a tendency to generate biased or harmful output, its potential for widespread dissemination and harm is greatly amplified compared to more constrained AI systems. What might have been a localized issue can become a global phenomenon almost instantly with GAI.
The potential for things to go viral, essentially.
In a way, yes. And I've heard the term algorithmic monocultures in relation to GAI. What does that refer to? It sounds ominous. That's a fascinating and genuinely concerning systemic risk that becomes more prominent with GAI, particularly foundation models. When a small number of dominant GII models become widely adopted and underpin numerous applications across different organizations and sectors, think employment screening tools, loan application processors, customer service bots, maybe even news generation tools, all relying on the same core LLM.
Everyone using the same engine.
Exactly. It creates an algorithmic monoculture. It's like if the entire global food supply suddenly depended on a single variety of wheat. If a disease hits that one variety, the impact is catastrophic and widespread. Similarly, with GAI monocultures, if that widely used core model has a hidden flaw, a security vulnerability, develops unexpected harmful behavior, or is susceptible to a new kind of attack, it can lead to correlated failures and increased susceptibility to shocks across all the multiple actors relying on it simultaneously. This creates a systemic risk that could potentially destabilize entire sectors or severely erode public trust.
That's a huge potential vulnerability if everyone's building on the same, potentially flawed foundation.
Let's spotlight some of the specific, perhaps unique risks associated with generative AI. What's at the top of that list, according to recent NIST guidance?
A very surprising and particularly impactful one, especially with LLMs, is the risk of confabulations, sometimes called hallucinations.
Confabulations, making things up. Essentially, yes. This refers to GAI's tendency to produce false or fabricated content, logic, or even citations for sources, but present them with extreme confidence and fluency, making them seem plausible. This can easily mislead users into believing and acting upon inaccurate information.
So it confidently asserts things that just aren't true. Can you give us a more concrete example?
Certainly. In healthcare, an LLM asked to summarize patient notes might confabulate symptoms or test results that never happened, potentially leading doctors to make incorrect diagnoses or recommend inappropriate treatments because they trusted the seemingly coherent summary.
Wow.
In legal contexts, as we've seen in some real cases, large language models have generated entirely fictitious case citations or precedents to support a legal argument. What's particularly deceptive is that the GAI might even provide logical-sounding steps for how it arrived at the incorrect or fabricated answer, further misleading users into inappropriate trust. It's not just making an error, it's actively fabricating convincing-sounding falsehoods.
That's incredibly concerning, especially the confidence part. And what about deliberately dangerous or harmful content?
That's another major risk amplified by GAI. These systems can generate inciting, radicalizing, threatening, or hateful content, or even provide instructions for dangerous or illegal activities, like building weapons or synthesizing harmful substances, often with greater ease, detail, and scale than previous technologies allowed. We've seen reports of LLMs providing violent recommendations or instructions for self-harm when prompted in certain ways. Text-to-image models can create disturbing or harmful images.
And I've heard the term jailbreaking in this context. People trying to trick the AI.
Yes. Jailbreaking refers to the deliberate manipulation of prompts or interaction patterns to try and bypass the safety controls and filters that developers build into GAI systems to restrict such harmful outputs. Even if systems are designed with guardrails to limit certain types of content, creative or persistent jailbreaking attempts can sometimes circumvent these protections, making it crucial for organizations to continuously monitor for these techniques and adapt and strengthen their safety measures. It's an ongoing cat and mouse game.
So even with safety measures, people are actively trying to get around them. This sounds like it could amplify existing biases too, the fairness issues we discussed earlier.
It absolutely can and often does. GAI systems, trained on vast data sets scraped from the internet and other sources reflecting societal biases, can readily perpetuate and amplify those existing biases. This leads to representational harms or consistently biased outputs that reinforce stereotypes.
Like the image generation examples.
Exactly. When prompted to generate images of professionals like CEOs, doctors, or engineers, many current text-to-image models often default to historical stereotypes, significantly underrepresenting women and racial minorities in those roles. They can struggle to produce non-stereotyped content even when specifically requested. This means that if the training data is biased, which it almost inevitably is to some degree, GAI models can disseminate and magnify those biases at a massive scale, effectively normalizing harmful stereotypes through the content they generate.
And misinformation and disinformation, obviously huge concerns with GAI. The speed and volume seem terrifying.
Indeed. GAI systems can unintentionally spread misinformation, that is, false or inaccurate content, often stemming directly from those confabulations we discussed, at an unprecedented scale and speed. More dangerously, they can be deliberately used to facilitate the production and dissemination of disinformation, which is false or misleading information created with the explicit intent to deceive, manipulate, or cause harm.
This is where deepfakes come in.
Precisely. Deepfakes, highly realistic synthetic audio, video, or photorealistic images generated by AI, become a serious threat here. They can be used to create fake news reports, impersonate public figures, commit fraud, harass individuals, or sow discord.
I remember that example of a single synthetic image, supposedly of an explosion near the Pentagon, causing a brief but noticeable dip in the stock market. That shows the real-world financial and social impact potential.
Exactly. GAI significantly lowers the barrier to creating convincing fake content, potentially eroding public trust in all forms of media and information. It can also assist malicious actors, from state-sponsored griefs to individual scammers, in creating compelling imagery, tailored propaganda for disinformation campaigns, or fraudulent content intended to impersonate others or manipulate opinions. It's a powerful tool that can be readily misused for significant societal harm.
What about data privacy, given the massive data sets these models are trained on, often scraped from the web?
Data privacy remains a significant concern, perhaps even more so with GAI. There's a risk of inappropriate inferences of personally identifiable information, PII, from GAI models, which can contribute to those allocative harms we talked about, adverse decisions made about individuals based on potentially sensitive inferences.
How does that happen if the model doesn't just spit out raw data?
Even if the training data itself isn't directly exposed, the model might inadvertently memorize and reveal sensitive attributes or patterns during generation, or allow users to infer private information that was never explicitly provided in the prompt but was latent in the training data. For example, a model might complete a sentence in a way that reveals someone's medical condition or location if similar patterns were present in its training data.
So it can leak information indirectly. And the environmental impact we mentioned earlier, is that even more pronounced for GAI?
It generally is, yes. The sheer scale of many state-of-the-art generative AI models, particularly foundation models with billions or trillions of parameters, means their training requires truly enormous amounts of computational resources. This translates into very high energy consumption and, often linked to data center cooling, significant water usage, resulting in a substantial carbon footprint and overall environmental impact.
And operating them isn't cheap either.
Correct. While inference, running the model to generate output, is typically less resource-intensive per query than training, the sheer volume of queries these popular models handle means their ongoing operational impact is also significant. While methods like model distillation or using more efficient hardware are being explored to reduce these impacts, the overall environmental cost of the current GAI boom is substantial. And as mentioned, measuring and reporting this impact accurately and consistently is still an emerging, though increasingly important, area for the industry.
So GAI introduces a whole new level of risk complexity and scale. How then do we apply the NIST RMF govern, map, measure, manage to these advanced systems? Does it need a completely new framework, or can this one adapt?
The RMF is designed to be technology neutral and adaptable, and its core principles absolutely apply to GAI. However, the unique characteristics of GAI mean that certain aspects of the framework become even more critical and often require specific adaptations or heightened focus within the existing structure. It really shows the framework's flexibility and foresight.
Okay, so where do we start in applying it specifically to GAI? What needs extra attention?
A key adaptation highlighted in recent NIST guidance is within the MA function, specifically calling for determining context-based measures to identify new or unanticipated impacts arising specifically from the GAI system's generative capabilities, MF 5.2. This often requires much deeper and ongoing engagement with downstream AI actors, the end users, affected communities, content moderators, etc., to gather feedback and identify unforeseen consequences or novel misuse patterns that might only become apparent after deployment in varied real-world contexts. Think of how quickly a new harmful trend or jailbreaking technique can emerge from widespread GAI use.
So listening very closely and continuously to the people actually interacting with the GAI and how it affects them in unexpected ways.
Yeah.
And if something goes wrong, say a model starts generating harmful content widely, how does incident response change for GAI given its potential for rapid spread? Manage 2.3 adaptations.
Right. The manage function emphasizes adapting incident response plans specifically for GAI systems. This means accounting for their potentially complex value chain, who trained the model, who fine-tuned it, who deployed it, and ensuring robust, rapid communication protocols with all relevant downstream AI actors in case of unforeseen risks or incidents. Given the rapid dissemination capabilities of GAI-generated content, quick detection, coordinated response, and effective recovery plans, which might include content removal or issuing corrections, are paramount. You often can't just fix the model internally and call it a day. You frequently have to address the potentially harmful content it has already put out into the world.
That makes sense. The response needs to match the speed of generation. And what about the source of the content these models generate? Tracing where it came from seems crucial for credibility and legality.
That's where content provenance comes in, mentioned as MP 2.2001 in the GAI profile. It highlights the importance of identifying and, where possible, documenting how GI systems rely on upstream data sources. Tracing the origin or influences on generated content is crucial, especially when dealing with potential issues like copyright infringement, intellectual property disputes, or tracking the source of generated misinformation. Knowing where the content ultimately came from, or at least the data that influenced it, is key to assessing its trustworthiness and managing related risks. Techniques like watermarking generated content are also relevant here.
Speaking of intellectual property and problematic content, how do you handle the vast, often opaque training data sets that GAI models use? It must be practically impossible to vet every single piece of data. That sounds like MG 3.100 sort of territory.
It is a monumental challenge, no doubt. MG 3.1004 stresses the need for organizations to take reasonable measures to review GAI training data for known problematic content, such as illegal material, CBRN, chemical, biological, radiological, and nuclear information that shouldn't be disseminated, or clear intellectual property violations. It also requires implementing reasonable measures during generation to prevent, flag, or take appropriate action against outputs that directly reproduce copyrighted, trademarked, patented, or otherwise sensitive material learned from the training data. This is a significant technical and policy challenge due to the sheer volume and often unknown or poorly documented origins of some large web scraped training datasets. Reasonable measures is the key phrase here.
It sounds like a best effort approach given the scale. And finally, a really important one for improving these models, ensuring human oversight and feedback.
Yeah.
How is that adapted for GAI, especially with all the user-generated prompts and interactions, like MS 1.3003 and Measure 3.3?
Human feedback is absolutely critical for GAI. MS 1.30003 points to verifying that those providing structured human feedback, like rating outputs or flagging bad responses during reinforcement learning from human feedback or RLHF, are ideally independent from the core development teams themselves. This helps mitigate internal biases, conflicts of interest, or pressure to approve outputs prematurely.
Keeping the reviewer's objective.
Right. And Measure 3.3 emphasizes establishing clear, accessible mechanisms for end users and impacted communities to report problems, provide feedback on outputs, and potentially appeal system outcomes that affect them. This direct feedback loop from the diverse real-world application of GAI back into its ongoing evaluation, fine-tuning, and safety improvement is absolutely vital for continuous learning and responsible development. These feedback mechanisms are essential for assessing how GAI-generated content is actually landing and impacting different social, economic, and cultural groups in practice.
This has been an incredibly insightful deep dive into AI risk management. It's crystal clear that AI is transforming our world in profound ways, from health and transportation to economic growth and scientific discovery. But it's equally clear that with this immense potential comes a unique and evolving set of risks that demand a proactive, structured, and continuous approach.
Absolutely. The NIST AI risk management framework provides a really solid, thoughtful guide for organizations trying to navigate these complexities. Understanding those inherent differences of AI risks, things like data drift, model opacity, the socio-technical dimension, and embracing those 7 trustworthiness characteristics: valid and reliable, safe, secure and resilient, accountable and transparent, explainable and interpretable, privacy enhanced, and fair with harmful bias managed is truly foundational to building and deploying AI responsibly.
And by breaking down the AI lifecycle and exploring those 4 core functions of the RMF: govern, map, measure, and manage, we can see how organizations can build these robust systems for oversight. Govern establishes the overarching policies, the culture, the rules of the game. Map defines the AI's specific purpose, its limits, and its potential impacts in context. Measure quantifies those risks with appropriate metrics and rigorous ongoing testing, and Manage outlines how to prioritize, respond to, adapt, and continuously improve in the face of identified risks.
And as we saw, generative AI, while offering truly astounding capabilities, definitely amplifies many of these risks and introduces new wrinkles through phenomena like confabulations, the potential for algorithmic monocultures, and the ease of generating misinformation or harmful content at scale. It necessitates specific adaptations and heightened focus within the RMS, emphasizing things like careful content provenance tracking, reasonable efforts in training data review, robust incident response for rapidly spreading issues, and establishing critical human feedback mechanisms.
So what does this all mean for you, our listener? Well, by understanding these concepts, the pillars of trustworthiness, the RMF functions, the unique GI challenges, you are now better equipped to navigate the complex AI landscape unfolding around us.
That's right. Whether you're involved in building AI, deploying it in your organization, making policy about it, or simply interacting with AI systems in your daily life, from chatbots to recommendation engines, you can now make more informed decisions and, importantly, ask more critical questions about the AI you encounter.
It really empowers you to be an active, informed participant in shaping this AI-driven future rather than just, a passive observer letting it wash over you.
And maybe here's a final thought to ponder as you go about your day. Given the dynamic, adaptive, sometimes unpredictable nature of AI, especially systems capable of continuous learning, risk management is truly never done. It's not a checklist you complete, it's an ongoing process of vigilance, assessment, reassessment, and adaptation.
That's a powerful point. It never ends.
What does this perpetual need for oversight and adaptation mean for our increasing reliance on AI in ever more critical domains, from healthcare and finance to national security and infrastructure?
And how can individuals like you contribute to this continuous feedback loop, helping to ensure that AI truly serves humanity responsibly, ethically, and equitably?
We encourage you to keep learning, perhaps by looking into specific ethical AI guidelines in fields relevant to you, or by applying the critical thinking skills and frameworks we've discussed today to the AI applications you encounter in your own life.
Ask the tough questions.
Exactly. Thank you for joining us on this deep dive.
Until next time, keep exploring.